Please give a warm round of applause again, Nate Baldwin.
Thank you. All right. It's the last talk. Hope you've all been having a great time. We're going to take a little bit of a trip. We are going to travel 2,000 miles west from here. Nestled below the desert plains lives the mighty Colorado River. Centuries of erosion have carved labyrinths of canyons, cathedrals of stone, and created some of the most iconic whitewater in the country. Now, navigating this water safely requires preparation and planning. When leading up to a large rapid, guides will pull their boats to shore and hike downstream to scout the water ahead. They take the time to observe the currents, looking for hidden obstacles, and planning a safe route before returning to their boat. You may wonder why any of this is necessary, especially if you're in an inflatable boat, but guides understand the importance of scouting, even with all of their experience. If they don't scout large rapids, they could risk the safety of everyone on their expedition. Hidden obstacles could cause them to get stuck, lose control, or flip their boats entirely. As we've established, I'm Nate Baldwin, and I've been navigating the rivers of the Southwest since I was a kid, canoeing, kayaking, and rafting through both calm and rough water. Professionally, I'm a designer who's worked on enterprise-level design systems for over 10 years. I've tackled some complex systems challenges, from token and theming frameworks to creating algorithms for adaptive spacing and color systems. And something that I've observed is that when it comes to complex system challenges, we rarely know the best solution when we begin the work. It's usually while we're building it that we realize what we should be building, and by then it's a little too late to redirect. You see, with design systems, we face the same critical moments as we do on the river, when a complex challenge demands that we stop, get off the boat, and scout what lies ahead. By reading unknown waters, we can identify the hidden obstacles before we begin the work. So today I'm going to share with you some things that I've learned to hopefully help you discover hidden obstacles, scout complex systems challenges, and bring clarity to your teams. Now, over the past 3 years, my team has grown from 4 designers to 20. We've also grown an entire engineering department that's responsible for web, iOS, and Android component libraries. And look at that, there's Stephanie. Hi, Stephanie. We're continually evolving our design language with refined aesthetic, algorithmic design for future flexibilities. And through the course of this evolution, our systems were put to the test. At the very core, our token system hit a breaking point. It couldn't support the growth and the evolving needs of our design language. It created a layer cake of problems that we needed to solve, starting with basic dysfunction. You see, our token system is only managed by 1 designer and 1 engineer, but there are 20 other designers who are contributing to this token system. Contributions were coming in the form of Figma specs, where a designer would type out the name of a token that they wanted to use for a component before the token ever existed in the system. There was no guidance on when to create a new token versus using existing ones, which resulted in inconsistent and redundant use cases, and there weren't any real-time standards enforcement. Instead, we had to rely on manual reviews. A content strategist and an engineer would review the name, and once they felt it looked good, then one of them would hand type or copy and paste the name into the code base of the token management system. And then once it was released, designers and engineers could finally pull back that token in and integrate it into their components. But this process took weeks, sometimes longer, even to add a single token into our system. This created a perfect storm, resulting in a maze of complex, unpredictable tokens riddled with inefficiency and inconsistencies that slowed our team down. And it made it difficult for everyone, both our team and our consumers, to find and understand tokens. Another problem we had to deal with came in the form of fragmentation. Our newly formed iOS team had to work fast. They were tasked with identifying what our spectrum should look like on iOS. But our token system couldn't support them. They couldn't customize tokens. And the bottleneck became a major blocker for them. So they decided to create and manage their own tokens. They created them as Figma variables with no connection back to our main core system. They used unique naming conventions for custom tokens, had their own approach to handling combinatory modes like light plus high contrast mode. And this resulted in redundant workflows. Right? We had two separate teams, two separate systems of essentially doing the same thing. On top of all that, our design team was continually enhancing design, like I said, with algorithmic design. We also had improved accessibility and enhancements and modes that we wanted to support. And we also wanted to support platform-specific color optimizations. Our design team had already begun integrating a new solution for variables in Figma that helped us to handle combinatory modes in a flexible and scalable manner. And we wanted all of these things to be centrally integrated with our token system. The problem was, none of these were technically possible. Putting it all together, we could see that our token system needed to be decentralized, but standards enforced, so teams had autonomy with clear guidance. It needed to be extensible, but centrally integrated, so that teams could customize, add, or remove tokens with transparency at a system view. And it needed to be sophisticated, but simple to use, so that design could innovate without the restraints of complex tooling. This wasn't just one problem. This was many complex, interconnected problems. We weren't sure about the intricacies of each of these and how they might respond to different solutions. A solution to one problem could become a technical blocker for another. And ultimately, what we needed out of this before we could do anything was clarity. We needed to disambiguate the different relationships between each of these problems. We needed to know what we could build ourselves versus what we could use existing tools for. And we needed to know what the proper user experience should be for our team to manage complex enterprise-level design tokens. Now, I'm a bit of an anomaly as a designer. I love to design with code. Building things is part of how I understand the problems themselves. This is a go-to process for me, especially when I'm handling a complex or ambiguous system. Exploratory prototyping is how I understand what problems we should be solving alongside potential solutions. So naturally, this seemed like an opportunity for me. The problem is a full end-to-end enterprise-level design token management system is a little bit more complex than the things that I've dealt with before. So I thought maybe this is an opportunity to use AI. Maybe vibe coding could help me. Okay, but I am not an expert in the area of AI. Full disclosure, I couldn't explain the difference between an LLM, a RAG, an MPC, or an MCP. See, I don't even know. So the thought of doing this with AI was a bit intimidating. And to give an example of what I could do, this is the first vibe-coded component I built. I wanted to make a wide gamut color picker. This thing was terribly non-performant. It was constantly getting stuck in infinite loops. The thing not only looks bad, but it doesn't work. Throughout the process of building this, though, I did start to realize I was actually learning some things. I was learning about the problems themselves, how the AI agent was trying to build things. I was also learning how to speak with an AI agent, specifically Claude's Sonnet models, which I found understood my way of speaking a little bit better than some of the others. So I knew that there was something here that I could tap into, but I just hadn't quite figured out how or what yet. And when looking at the challenges of a token management system, I believe that the core issue begins with the data model itself. Now, I'm going to be a little provocative. Please don't hate me. But token models in our industry right now are fragile and flexible and incomplete. And for what we are trying to do, the data has to be stable, flexible, and complete. Otherwise, it would be of no use to us. And having worked with tokens for some time, I had some opinions about how we might do this a little bit better, at least for an authoring environment. But I had never actually formally defined JSON schema before. So what I ended up doing is just chatting with Copilot and Claude, showing it some sample data with my idea of how we might put these things together. And it helped me to refine it and put it into a JSON schema format. I also asked it to compare my schema against the W3C spec, other design tools and design token models, even Figma's variables, which do some things pretty well. Ultimately, what I wanted to make sure is that what I was creating was as stable, flexible, and scalable as possible for use in an authoring environment. Now, not all of its recommendations were that great, but it did help me get a sense of what I wanted to incorporate into my schema. And through a couple of additional refinements, I got to a point where I was pretty happy with the schema, and I had Cursor create a starter project with schema validation and some basic testing. That's when things started to get really interesting. I had Cursor help me build a web app where the schema was the source of truth. And at first, things were looking pretty good. It was all compliant with my schema. The interactions weren't too terrible. The design was okay. But I was able to iterate, refine workflows, add features, migrate the UI. Things started to look pretty good. Like, this is something I could actually start building. The problem is, at one point, my progress completely stalled. I found that when I started building, I was building features and enhancements to problems I already had an idea as to how I wanted to solve. But when it came to other things like creating an algorithm builder, I had no idea where to start. So my prompts for those types of features were much more vague. Cursor would do its thing, and it sometimes would look like it's working until I'd test it out in the UI, and I'd be disillusioned by the fact that it actually was not, like this spacing system that returns not a number of pixels. Cursor would tell me that everything was working just fine. I'd continue trying to iron out all the bugs, but every time it just kept saying it was working, but it wasn't. And this was really frustrating. You almost feel gaslit by AI. It's telling you it works, but it clearly does not. And so here I was, and I realized I'm in the exact same position that I was with my color picker. Even though things aren't working, I'm learning a lot. Just by watching what the AI is trying to do or how it's trying to solve a problem, I'm learning a lot more about the problem itself as well as the potential solutions. Now, this is where I want to introduce this first method to you today. You probably already do this. I'm calling it branching and burning. It's where you just create a branch specifically for AI explorations and just delete the code when you're done. And the process is something like this. Anytime you're building and you encounter a feature that you aren't quite sure how you want to solve or how you should solve it, create a new branch specifically to let AI explore. You can start with a vague prompt. It really doesn't matter the format that you use. If you want a better starting point, you can just use a chat agent and ask it to format a prompt for you and just include some of the information along the way. It does pretty good. And then from there, let AI do its thing. You can continue iterating, refining it. Sometimes you'll end up with a feature that is usable. Other times, not so much. But that's okay, because the purpose of this is not the quality of the output. Quality of the output doesn't matter. What matters is the quality of the insight, what you're able to learn and understand through that process. So take notes, get a sense of what you might want to do or how you might want to solve it, and then just burn it. Delete the branch, keep only your insight. What this helped to reinforce with me is the importance of embracing productive failure. And you can really help prevent AI from screwing up your prototypes by using this safe method of disposable exploration, right? Keeping it siphoned off. Now, after doing these explorations, I learned some ideas, but I still had to do something with them, right? Most of these explorations resulted in deleted code. So what I needed to do is make sure that when I implement the feature, it's also aligned with the rest of my project, upholds the same amount of standards, and ultimately feels like it's production quality. So the thing with experimental prototyping is that it's about learning what problems need to be solved alongside potential solutions. And the closer a prototype is to production quality, the more accurate those insights are. So a buggy, incomplete prototype can sometimes do more harm than good. It could suggest that something will work that actually won't. So I wanted to make sure that this was as production quality as possible. And it took me a while to figure out a way to do this, right? I'm new at this. How do you do this? And the way that I figured out was using a 4-step process for structured prompting. This is all about making sure that what we're telling the agent to do is very well defined. We're giving it specific constraints and instructions to do what we need it to do. And it starts by context priming. Now, what we do here is we start by asking the agent to perform a thorough and investigative analysis of features or integration points for the workflow or feature that you're trying to introduce. Tell it to do 3 to 5 separate analyses from different perspectives, so it has different things that it's taking into account each time. I then tell it to do a meta-analysis of all of those alongside a final evaluation of the whole project to make sure that its results are accurate. I have found that this ridiculous level of redundancy is actually pretty helpful. It helps to make sure that the AI agent doesn't miss details or make assumptions. If it doesn't have a clear picture of the systems that it's working with, it will make assumptions. So you want to eliminate as many of those opportunities as you can. Here we're also going to tell it to use this as context for future prompts. Let it know that it's going to revisit this information. But also tell it not to make any code changes with this request. Another frustrating thing that I found is that when you do an analysis like this, sometimes the AI agent will see things as opportunities and it will just run off and try to fix them. So you want to make sure it doesn't do that here. After it's performed this evaluation, then we move on to detailed planning. And this is the more complex of the prompts that we need to write. We start by stating our intent. We want the agent to create a comprehensive implementation plan for our new feature. Make sure that it's referencing the analyses from above, and this is where you also include details from your experimentation, everything you've learned about how you want to solve for the new feature. If you're not sure about something, or if you have a hunch, it's good to include these too, but use language like, I think it might have to do with X, or it could be solved by Y. I found that Claude and the Claude Sonnet models are pretty good at identifying that as optional direction rather than explicit instructions. Next, we're going to tell it to format the plan as prompts for an AI agent to follow. Pro tip here, we are just telling the agent to write its own prompts. And this is really helpful for us here. Clear, actionable prompts are going to help to ensure a greater likelihood of success in the end result. We do want to include some additional detail, though, here as well, like telling it to reuse existing functions and components. Even if you have this explicitly laid out in your project rules, sometimes it will ignore it, especially if it's just creating the plan. So be explicit here. And we also want to tell it to incorporate tests along the way. Something that I found is that the larger the amount of code is that the AI agent is generating, the worse of a situation you're in if it hasn't been tested iteratively through each phase of the process. You'll end up with a feature that is so buggy that not even AI can figure out where one bug ends and another begins. So having it iteratively test at each phase is critical. So it makes sure that the thing that it was doing at that moment is as accurate as possible before it moves to the next. It's not going to guarantee a bug-free prototype, but it will help you get a lot closer to a usable result. Since redundancy is important, we're going to tell it, adhere strictly to our project rules and any technical decisions that you've documented along the way, which is another good thing to do as you're working, continuing to document those in a markdown format so the agent can come back and reference that later on, making sure that as your project evolves, it's keeping up with it. Finally, once again, we're going to tell it not to make any code changes. Again, it's kind of like a dog. After you throw a ball, it just wants to go chase it, so tell it to stay put. And last but not least, I found it very helpful to tell the agent to ask clarifying questions at the end, as well as preserving existing design and functionality. From this prompt, it's going to generate a thorough plan, and that's where we can move on to plan refinement. If it had any clarifying question, it's going to include those. So we're going to start by answering those, be as clear as possible with these questions. But if you're not sure about something, go ahead and ask the agent what it means. Something that I've also found very helpful is that we're not just vibe coding. We're not just telling AI what to do. This dialogue between us and the system is more like collaborative coding with AI. The more that we can answer to its questions and it can answer to ours, the better understanding both of us have, right, for getting a good solution. After you've answered the questions, it'll update the plan. Make sure you manually review it. AI is not good just completely on its own without human intervention. So look that through. Make sure it's not including anything that's not necessary, that it's not omitting any important details that you do need it to include. And once it's good to go, make sure to save it to your project. AI chats will reach a limit, and you want to make sure that you can reference this later on. After it's saved, we move on to implementation. Paradoxically, this is the easy part. Since our plan is already formatted as very thorough, explicit, clear, structured prompts with iterative testing, all we really have to do is tell the agent to implement the plan. It is still a good idea, though, to tell it one more time to preserve existing design and functionality. I've had that happen too many times. I may be a little overly cautious, but making sure that you're explicit here is important, that it doesn't go screwing things up that it shouldn't be messing with. And also making sure to tell it to adhere specifically to your project rules. Now, the result of this is a very well-informed execution of a feature. It's not going to guarantee a perfect result, like I said, but it is going to be much higher quality than prior experimentations or vague prompts. And I've used this four-step process for some of the really complex features that I implemented and UI migrations. Context priming ensures that the agent has a clear sense of your existing project and systems. Detailed planning is how we essentially tell the agent to create its own prompts for us. Plan refinement is how we make sure that the agent is going to do explicitly what we tell it to do and want it to do. And then implementation with this approach is much easier. Following this method, I learned the importance of creating informed prompts. It's not so much about how you structure it. It's more about how much information and context the agent has to work with. And so, yeah, I use this on plenty of the different features that I was able to implement. And something else I've learned is that really with AI, the quality of the input directly affects the quality of the output. So here's where we're trying to make sure that input is as high quality as possible. So following this structure, I also found, it unlocks AI's potential, really, creating that structure. So it's not necessarily like AI is going to be able to do these amazing things all on its own. The structure, the context, that is what really unlocks that potential. So it can do amazing things that you actually find valuable. And using this process, I continued to iterate on the prototype for several weeks. I was able to implement a full end-to-end token management system that met with the architecture that we'd already kind of predefined for separating some of the technical layers, the UI, storage, transformations, published resources, as well as a model for levels of customization. And this really helped to unlock democratization and team autonomy for token management. But the prototype alone didn't fulfill its purpose. I still had to share this with the team in a way that helped to elevate everybody's understanding of the problems, the nuanced challenges of enterprise-level design token management. So we got together for a focused workshop on our design token system where I was able to reiterate some of the primary customer pain points that we were looking out to solve. Right? It was really important that we began these conversations with a clear understanding of what had to be resolved, what we had to do. From there, I used a metaphor to describe the difference between extensions and theming. This was a really complex topic for our team, and there was a lot of discussion on it, but reducing it to a metaphor really helped to disambiguate the different relationships, where our product ecosystem is like this shape sorting box. A product is a colored shape. The shapes are the platforms like iOS or web. The colors are the themes like the products that we use. So these are different interchangeable things. The data needs to change shape in order to fit into certain holes for certain platforms. So that helped kind of illustrate for the team. I also took some time to talk about multi-dimensional tokens, which essentially are tokens that have a value that changes based on combinations of modes. Now, rather than us addressing modes as a singular concept, right, we needed to look at modes in terms of mutually exclusive groups like color scheme, contrast, density, and language. Our existing tool only supported up to a single dimension in that regard. You could only have color scheme. You couldn't combine it with contrast mode in the data system. But we knew that teams like iOS had to have that now. Other teams wanted that as well, but we knew that this was an immediate need. On top of that, our design team wanted to make sophisticated and nuanced design decisions, like changing font weight based on light or dark mode, but also based on contrast mode, or even language. Now, what I had to communicate here was the pitfalls of incorrectly solving for multidimensional tokens. We needed to have the flexibility for supporting this, but what we had to watch out for is known as combinatory explosion. This is the hidden obstacle. Every time we add a new mode or a dimension of modes, the permutations of combinations of modes to resolve some data is going to grow exponentially. I needed the team to be acutely aware of this challenge. It's something that we've encountered before, but I wanted them to be aware of it so that they could see how within the prototype we could elegantly mitigate that issue. From there, it was time to work through some demonstrations. I walked through key workflows, highlighting features and how they addressed specific customer pain points and technical challenges, like how we could enhance our token naming experience by having an actual taxonomy system, a bank of terms that could be independently managed and documented. These terms could then be scoped so that a taxonomy can only be used for specific token types to help with the user experience and additional guidance. Using a taxonomy system like this, naming tokens was no longer about hand typing a name, it's about choosing terms from a predefined system, applying those to the use case for your token. And alongside this, we could then define a rule for how we order our taxonomies, and we could combine that with formatting options for each platform and just generate the string names for teams that rely on them. A key feature of this approach is that whenever we change the name or a term in our taxonomy system, the data will not break. Anytime we rename tokens within this system, they will not break. They reference UIDs. The taxonomy is just additional data included in the token. So we're no longer relying on a key value pair, which is a major fragile level of fragility in existing systems. We were also able to demonstrate how, oops, wrong direction. There we go. Demonstrate how we could support platform extensions using GitHub as a platform. Right? The schema has contracts between different data files. So you can have an ID and a URI that's cross-referencing one another. We can use GitHub's API to then link existing repositories or create entirely new repositories for some of these extensions. And when we create new repositories, we can scaffold it with some basic JSON that includes that contract data, as well as formatting rules. That way, whether it's a theme or a platform, the system knows how to gather all of this data, where to find it. So if it's in a central repository, if they're in separate repositories, it doesn't matter. All of that data gets merged together in a single UI, so that we can have a holistic view of all of the different token changes, the overrides, the omissions, as well as analytics and more. This really highlighted to our team how we could leverage GitHub for some of the more complex features that we were concerned with. Multi-source, multi-tenancy, permissions. We could leverage existing tools for this. It also showed how we could reinforce Git best practices in the tool itself, protecting main branches and then forcing commit messages anytime you save, as well as anytime you submit for review, which will create a pull request directly to the source repository that's being edited. I showed how we could support multi-dimensional tokens in a fairly simple user interface. So every dimension has a default mode, so we only have to define an override for combinations that have one. And look, I even got my wide gamut color picker to work. I was happy with that. And lastly, how properly structured data allowed us to transform and sync the data with one of our more complex use cases, our custom Figma integration. Here, every dimension is created as a mode, or as a every dimension is created as a collection with its mutually exclusive set of modes. Now, if a token changes value in any one of those dimensions, it'll need to have a variable representation in that collection. If it changes values based on multiple different modes or different collections, it needs to be represented in each of those as well. So we have this process of daisy chaining intermediary variables through levels of collections. This threading of aliases is what allows us to publish a very simple customer-facing collection like color, while also supporting customer-friendly facing options in Figma for changing independent dimensions like color scheme and contrast. Throughout the demonstration, I made sure to tell my team that the prototype was not the solution, right? I had gone off and tried to do some exploration with this, but even though it solved some of these problems, it wasn't a good solution in and of itself. The purpose was not to solve the problems. The purpose was to help the team have some clarity on the problems and the nuances of the challenges along the way. By the end of the demonstration, I ended up taking them on a journey, talking about the different challenges, the customer pain points, things that we needed to address, talking about technical challenges as well, and uncovering all the hidden obstacles that we had ahead of us. At the end, we had enough clarity to begin planning and moving forward. At this point, we were ready to get back on the boat. Through this project, I learned some things as well. I learned, again, the importance of embracing productive failure. The more I failed, the more I learned. I learned the importance of creating informed prompts. We really unlock AI's potential when we have structure, context, and well-informed prompts, as well as the importance of taking my team on a journey. The prototype doesn't speak for itself. It was really important to take them through this and help them along the way. So how do we uncover the obstacles of a complex system before we even know that they exist? We uncover hidden obstacles by prototyping for discovery, not just validation. This is how we read unknown waters, exploratory prototyping. It's how we can ensure that the solutions that we build are not going to eventually get us stuck. This is how we prepare for scalability, flexibility, and growth. Exploratory prototyping is how we find the obstacles before the obstacles find us. So the next time that you're encountering a complex systems challenge, resist the urge to just run the rapids. Take the time to stop, get off the boat, scout what's ahead. By using some of the methods I shared today, hopefully you can also use AI to help you explore more and explore faster. And by taking your teams on a journey, you'll become like a river guide, scouting, reading unknown waters, uncovering hidden obstacles, taking your team on a journey so that together you can reach your final destination. Thank you.
Oh, thank you so much, Nate. Thank you. Please join me for a conversation over here. Oh, this is exciting. I think I really like the fact that you brought up about very often when we actually start playing with AI, it feels like we just want to get to the solution. Mm-hmm. And sometimes it's the journey there where you actually learn the most, when you actually understand what works and what doesn't work and what you need to kind of keep in mind there. Yeah. This is really interesting. One question that came up very quickly as well, which kind of relates to that. I love your structured 4-step process. Collaborative coding requires quite a bit of planning and I guess it probably must have taken hours to write these prompts, right? Mm. Do you use it as a template or preset? And also, how do you deal with hallucinations in general? Because these are two questions in one.
Yes. So the prompts that I shared were some actual prompts, and they didn't take too long to write themselves. I don't think that we should spend a lot of time writing the prompt. That's, again, where like, if you've got the context, AI can help you write a prompt to sidestep that.
Right.
Yeah, and then hallucinations, I guess, beating your head against the wall,
Right.
looking out for them, and that's why like making sure that everything is you're following good practices and keeping everything on a branch, because when it starts to really mess up, you want to be able to just throw it away and start over if you need to.
Right. That means that you asked the AI to write these prompts based on the structure that you predefined, or is it how did these prompts emerge?
Yeah. So the prompt that I shared for detailed planning,
Yeah.
that is essentially the instruction to create the plan.
Okay.
And I've followed that structure just subjectively for many of the different features. I didn't have a template created. I just kind of over time was realizing some things that I should include or some things that I should repeat, or even like how to order some of those things, like adhering to project rules, putting that at the very end.
Yeah.
I have noticed can sometimes play a role.
Also, it's just very useful for me to keep in mind that every now and again it might be a good idea to save that thing into a separate file. That's very helpful.
Yeah.
Okay. There is well, we have wonderful people who have opinions, strong opinions. One of the questions is, why use AI instead of collaborating with your team of engineers?
That's a great question. Yes, so it's about really fast, sloppy exploration, learning. This was a way to bring back to the engineering team who, that chart of two people, the one designer, one engineer, okay, we got one engineer who is working on this, who has got a lot on their plate. This is a way to not put more on their plate in forcing them to solve the problem or do these explorations. It's a way to take a weight off and say, here are some options, here are some things that we can look out for. It was actually really helpful to share this with our engineering team, because there were folks who believed that we might need to start from the ground up. We were really afraid of having to do that. There were some folks who were like, we have to just make some iterative improvements. And by going through this with the team, we realized that some of the things that we thought we might have to build from the ground up were absolutely doable by just iteration. So it gave us a straw man, essentially, to just poke holes at and find the weaknesses so that we knew where engineering should go from there.
Okay. Frank. It's always Frank. Frank is asking, explain again, please, how changing the name of the token does not break things. That flew by me too quickly. Thank you. That's all, I think, and maybe a few notes on that. Just for context, I think you said it's using a UUID behind the scenes. I guess because we're using Figma color tokens transferring the storybook, we're tied to token names, not UUID.
That's a great question. So this is my opinion. Tokens are just an idea. And we've got it in our heads that they're a key value pair. And that makes sense as a consumer of a token. So there's two different kind of halves of the equation. There's the experience of consuming tokens and your perception of a token based on that consumption model. And then there's authoring. And those two are very different. And what we see is that when you try to author tokens, and anytime something does need to change, if you're stuck in the consumption model where it's a key value pair, then any change is going to break everything. There's manual cascading that you then have to look through your entire code base to say, okay, we changed accent to CTA, so now I got to find it everywhere, got to make sure, right? That's really meticulous. And so what we're doing is we're saying these names are just an output. It's an output of a classification system. So you have an idea, which is just an object in data. You give it a UID because that's completely objective. There's no subjectivity to it, but what you name a thing is entirely subjective. So we want to eliminate that so that the system itself can always reference it regardless of how it's classified. Then there's a taxonomy that you're applying to them. So these different terms, which also reference UIDs, not the actual words themselves. So again, like I said, you can change the terms you're using from accent to CTA within the system and it won't break. Now, that means that within this authoring environment, we can be extremely fluid and flexible. We can change everything and it's not going to break. The consumption end, if we don't bridge that gap, very much would break, right? So what we're trying to consider is, like, if we're moving to this kind of a model, keeping track of classification evolution, token naming evolution, so that you can revert or publish to some of these existing names for backwards compatibility, or even just for automating migration guides, right? The data is there for this object, even if you've changed its name, whereas in other methods with the key value pair, the whole thing has kind of disappeared once you change its name. Now it's something else. So we want to keep that tied.
Yeah, that's interesting. Smart. Victor is wondering, who actually built that final solution? Was that you building with AI or your engineers?
The final solution of what I was showing,
Yeah,
or
I think so.
the actual system? This final solution is just the prototype. That's not what we're using. That was what I was sharing with my team. That was a vehicle of communication. So the engineers on the team are working on an actual solution for us. There's a lot of things that I didn't take into consideration here that engineers are very acutely aware of, especially at enterprise level. There are certain standards, certain tools and things that they have to use that as a designer, I'm not aware of. So I use it more as a way of just expressing ideas and potential and possibilities so that they can see some of these ideas. And as a team of designers and engineers, we can look through how we might want to solve it, and then engineers build the actual thing.
Mm-hmm. Sam is wondering, what's the system you're using for managing tokens again?
Nothing. I'm not going to say.
Okay, fair enough. Check. And then another question, a very quick question, I have to say. Adobe Spectrum 2, when is it coming out?
Well, you were hoping for October, right? No, I can't.
I mean,
No, I can't.
I don't mind. It can also be late October.
Yeah, Spectrum 2, I can't. Okay. I couldn't say. I'm not too sure what the timelines are for it, but it's in beta. There we go. There's your
Okay.
answer.
No, fantastic. Well, we have a few more. We have very little time, so I'm just going to run through it. First of all, I mean, they are slightly more, as we're closing the conference, kind of funny. How many Amtrak trains have you mooned on the Colorado River?
How many Amtrak trains have I
Mooned.
mooned?
Yes.
Next question.
Okay. Okay, that's really goes quickly, really fast. I mean, I'm running out of questions here, but I do have some here. Hold on for a moment. I just need to find it here. Okay, here we go. Oh no. Oh, no, I need to scroll. Why do I need to scroll? Hold on. Okay, here we go. Yes. So I was supposed to ask you specifically over here. You can fold super tiny paper cranes.
Yes, I can.
Can you tell us more and how this came to be?
Being very bored and just, I think I started in high school. So you know the mechanical pencils that you can pull the eraser out? So I, out of pure boredom and curiosity, thought, hey, I wonder if I could fold a paper crane so small that it could fit inside of there. And so, yeah, I can do that.
So they're very, very small.
Very small.
Okay, so this is like you also do that while you're waiting for AI to respond?
Oh, yeah.
Okay, so this
Many
keeps you
paper cranes.
Oh, fantastic. And then finally, just as we're wrapping up, so like looking at this, it's very interesting for me to see things showing up and kind of almost from ground up and exploring how can we do this and figuring out, especially when it comes to these complex projects. Is there, like, let's say, a dream project that you want to take on one day? Which you think, yeah, if I only could do this, that would be amazing.
Yeah. I was asked this before, and I forgot what I said.
I know what you said.
What did I say? Because you know. What was
I do.
Oh, yeah. So my dream project, I was like,
This is totally not premeditated.
this is completely not scripted at all.
It's not. No.
I want to get back into painting. Like I said, I started my career going towards fine art, and every now and then I paint a little bit, but what I really want to do is just large-scale, hyper-realistic paintings, something of like a desert sunset, or anything really from the Colorado River. I love the visuals of like flash floods in those canyons where it just is impending doom, and it just is so beautiful. And so, yeah, I would love to do something like that.
So Q4, 2025?
Q4, yep. before
For
we're out
the
of
end
data?
of the year. Yeah. Sure. Well, with this, if you have any more questions to Nate about design tokens or anything else, or AI prototyping, you can also find Nate, of course, right after this outside for maybe a few minutes or so. Right? Thank you so much, Nate, for being with us and sharing all the wonderful insights.
Thank you.
Fantastic.